In this video lesson, we will learn about cones and pyramids. So first, I'm going to define these. A pyramid has a base, and then there's another point somewhere above the base, and that point is connected to all the vertices of the base, like this. You can imagine like the pyramids, the Great Pyramids of Egypt. You could have a triangular base. It doesn't matter what shape the base is. The pyramids of Egypt have square bases, for example. And of course also cones. So cones are very similar to pyramids, but their base is a circle. And here I'm just adding the little three-dimensional looking lines. So that's what these objects are. And what we're going to learn is how to calculate their volumes. So what's important for calculating their volumes, very similar to cylinders, is the area of the base. So here I'm specifying that's a square pyramid, and this is just the cone. And to calculate these volumes, so the volume, which we always abbreviate as V, is equal to 1/3 B times H, where H is the height, and B is the area of the base. And the height is the distance from that extra vertex above the base to the base. In the specific case of a cone, since we have a circle, if the circle has radius r, then the base area is pi r squared, because that's the area of a circle. So the volume in that case could also be written as 1/3 pi r squared h. So now we'll do some examples to work out these formulas. In the first problem, we're calculating the volume of this cone. The first step is the area of the base. It's a circle, so the area is pi r squared. The radius is 2. We plug in 2, we get 4 pi. H is the height. That's just 6. It's written in the diagram. The volume is 1/3 times B times H, which is 4 pi times 6. So we simplify this. We plug it into our calculator, and we get 25.13. And so now let's do another example. The base of this pyramid is a rectangle. Find its volume. So we want to find its volume, and the volume is the base area times the height. So the first step is the base. And here I'm redrawing the base flat. And it's this rectangle with sides 2 and 4. And as you probably remember, the area of a rectangle is the product of its two sides. So 2 times 4. So it's 8. Next, we look at the height. The height is 6. That's the distance from that top vertex to the base. And we calculate the volume. It's 1/3 BH, which is 1/3 times 8 times 6. We just plugged in the things that we know. 6/3 is 2, so this simplifies, and we get 16 in the end. The volume is 16. All right, we're ready for a last problem. A pyramid has a height 4 and a square base with side length 4. What is the radius of a cone with equal height and equal volume? So first, let's figure out this pyramid. I drew the square base, and then that point on top, and now I'm connecting these lines. So this is what our pyramid looks like. All right. So we know that it's got height equal to 4. Here I'm drawing, that's that height. And it's got length 4. And the base is a square with side length 4. So we want to figure out the radius of a cone that has the same height and volume. If it has the same volume, then we need to figure out what the volume of this object is. So first, let me draw this cone. This is what the cone looks like. And it's got the same height, equal height, so that must be 4. and unknown radius. So I'm just labeling it as r, and r is what we will be solving for. So now we calculate the volumes. We calculate the volume of the pyramid. It's 1/3 times the base area times the height. The base is just the square with side lengths 4. So we have area equal to 4 squared, which is 16. And the height is also 4. So the volume of the pyramid is 1/3 times 16 times 4. And when we simplify this, we get 64 over 3. And this volume of the prism, I'm just going to rewrite it over here, is also the volume of the cone. So what we would like to do is use that to calculate the radius. So let's write out the formula for the volume of the cone. Well, we know it's 1/3 times the base area times the height. The base is this circle of radius r, so it's got area b equals to pi r squared. And r is unknown, so we can't plug anything in yet. The height is 4, that we know. And we plug this into our formula for the volume of the cylinder. We get 1/3 pi r squared times 4. And that equals to 4 over 3 pi r squared. Now this VC, volume of the cylinder, is equal to VP, volume of the prism. So we apply that, and we can write that this, because VC equals VP, we can write that 4/3 pi r squared is equal to 64 over 3. So now we just have an equation with some numbers and r, and we can solve that. So I'm going to rewrite it over here. 4/3 pi r squared equals 64 over 3. And now let's solve it. So first, we can get rid of those 3's on the bottom just by multiplying by 3 on both sides. We get 4 pi r squared equals 64. And now we can divide by 4 pi on both sides. And this simplifies to r squared equals, and 64 over 4 pi. And that actually simplifies a little bit to 16 over pi. So to solve for r, we just take the square root. Square root of 16 over pi. We plug this into our calculator, and we get 2.26 is the final answer. So I hope that this was helpful, and thank you for watching.